All right, Algebra 1, welcome back. Good morning, good afternoon, good evening, all the normal welcomes that I can give to you guys. Hey, I hope you guys are somewhat enjoying these videos. If I'm being honest with you, I'm kind of getting used to making them right now. I've made probably 30 videos up to this point. Maybe they all haven't been released, but I've made a lot of them, and just really hope that they're helping you guys. So please, please, please be watching these videos and rewatch these videos. This chapter, I know that there's a lot of new stuff kind of being thrown at you, along with stuff that is incorporated from what you just did in chapter 10, and so I just hope that you are sticking with it. Just keep trying and keep trying and keep trying. Email me, message me, all those different ways that you can utilize to better understand the material. And please, please, please be watching these videos. All right? Okay, let's get into it. We are in section 4. This is titled Adding and Subtracting Rational Expressions. Make sure that you guys are always following along in your textbook with these videos. So please pause the video, get that textbook out, write down all the info that you see on the board here. All right, so we're going to be jumping into it, and we're going to have some problems that are pretty quick, and then we're going to end with a problem that takes some time. All right, so you got to follow the whole video, pause it, watch it, all that stuff. That's the only way you're going to really understand this the best you can. All right, so our quick review, this upper line here, is remembering that fractions, when you are adding or subtracting these fractions together, you have to have a common denominator. All right, so adding and subtracting with a fraction, yes, you have to have a common denominator. If you are multiplying and dividing, that's the exception. You do not need to have a common denominator. So here's our quick review. Basic fraction, what if you have 3/5? You are adding that to 4/5. You'll notice we have the same common denominator. Then you can proceed and do the math. Simple enough. You're going to add these numerators. 3 plus 4 giving you 7. You get 7 over 5. Great, that one would be done. Now, over here, what if we have a different denominator? You're looking at 3/5 and you're looking at 3/4. Now, just because the numerators are the same doesn't mean that you are just proceeding. You have to get a common denominator, and 5 cannot become 4, and 4 cannot become 5, so you have to figure out what's the next best number. Well, they both could become 20. How so? Multiply them together. So if I take every number on this side and multiply it by the 4, and then every number on this side and I multiply it by the 5, key thing, what you do to the bottom, you have to do to the top. Then let's see what we get. We're looking at now a 12 over 20, because 3 times 4, and a 15 over 20, in this case, because 3 times 5. Then you can proceed, and 12 plus 15, you're looking at 27 over 20, and you're good. However, we're not just dealing with simple basic numbers here. We are dealing with expressions. We are dealing with variables. We're dealing with exponents, and it's a little bit more involved. All right, so let's take a look at two problems right here where the denominators are the same. Okay, just like this one up here, if the denominators are the same, we can then proceed and start to simplify the numerators. So if these denominators are the same, I'll tell you what I'm going to go ahead and do is I'm going to rewrite this over the one common denominator, which in this case is x. I'm going to take my numerator and I'm going to put it all together. 2 plus x plus 1. And if you look at that, 2 plus x plus 1, there is a common or a like term, the 2 and the 1. So 2 plus 1, this whole thing ends up simplifying to x plus 3 all over x. All right, common denominator, x was given. Go ahead and put it over that one common denominator, and then immediately look to your numerator and simplify what you can. Now let's do the same thing down here at this problem. where you'll see right off the bat common denominators. That's great. But this minus sign right here, this is going to play a vital role in how you distribute to what is to the right here, and right here. So that negative sign is now going to make that 2x become a negative, and that negative sign is now going to make that negative 3 become a positive. So let's put it all over the common denominator, 2x minus 1. The 4x plus 1, that stays. We didn't do anything with that yet. Then this becomes a minus 2x, and this becomes a plus 3. So what you should see here, as I cross over, is we're looking at a 4x minus 2x. Those are like terms. A positive 1 and a positive 3, those are like terms. So let's go ahead and we'll write that down here. 4x minus 2x gives you 2x. Positive 1, positive 3 gives you a positive 4 over a 2x minus 1. Now, in this situation, you cannot go any further than what is given. Even though you can take a 2 out, if you were to look ahead and see, oh, well, that's a 2, that shares a 2, I could factor that out, that's not going to help us, okay? So you don't have to go any further, and this problem right here is now done. Now, what you should remember in past videos is that you can't just go crossing out a 2x over a 2x. Why not? Because this sign in between, it's bonding them together. All right, it's almost like a chemical bond if you were to think of it in chemistry, where the 2x cannot be separated from the 4. It's either all of it or none of it at all. Okay, so that's why this stays as is. You cannot cross out the 2x's. Please remember that, because in problems you're going to see on the test, every year students make that mistake. Don't be the student that does that, all right? Don't make that mistake. Okay, let's move on to a little bit more difficult problem here. All right, wake up, take a breath, because it's going to get a little bit more intense. Here we go. Now, notice, denominators, not the same, not common, all right? So we're looking at something like this, where we're thinking, can I make a 2 become a 5? No, I can't. But what number does 2 and 5, what can they both go into? What can they both become? The answer there is 10. So 2 and 5, they can become 10. Great. But what do I do with this x, and what do I do with this x to the 4th? Now, can x become x to the 4th? Yes, it can. If you take x and multiply it by x to the 3rd, what would that be? That would be x to the 4th. So, the x to the 4th, that is going to be my common denominator for the variable. And for the 2 and the 5, I'm going to make them become 10. And that's going to be my common denominator for the coefficient. All right? So what do I have to multiply this side by? I just have to multiply this side by 2. Because I'm keeping the x to the 4th, but I want that 5 to become a 10. That's where the 2 comes in. And don't forget, what you do to the bottom, you do to the top. But what do I multiply this side by? Well, there's a little bit more involved here. I multiply it by a 5. That's great, because the 5 and the 2 will make 10. But I need that x to become x to the 4th. That's where x to the 3rd comes in. Okay? So, this side right here will become 10x to the 4th. 7 times 2 will become 14. The denominator over here will be the same, 10x to the 4th. 5 times 2 is 10. X to the 3rd times x is x to the 4th. Good, now I have a common denominator. Now what about here? 3 times 5 is 15, and then x to the 3rd just gets brought down with it. All right? Notice, common denominators. Let's just write this over the one common denominator of 10x to the 4th, and then my numerator, 15x to the 3rd plus 14. If you look closely, there's nothing else you could do. This problem is now done. Right there, okay? Take a pause, go back, re-watch that, follow it step by step. All right, do that thing that you can slow the video down or speed the video up, whatever is going to help you guys the most. Now, this problem right here. All right, this one is the biggie, so really stick with me. Okay, you're going to notice a lot of things. I have a trinomial. This will be factored. I have a perfect square binomial. This will also be factored. And then I have this minus sign. That's going to play a role just like what happened over here in the second example. It played a role here. Let's start it. Okay, so I'm going to put an equal sign because we are going to start by factoring these denominators. Sorry to squeeze on space a little bit here. Hopefully that all fits in. So this trinomial factors to x and x. There's a plus, there's a minus. 8 can be created by 4 and 2, which is good because 4 and 2 could make 2. I'm going to put the positive 4 and the negative 2. 4 minus 2, 2. Perfect square binomial, x, x, plus, minus, 2, and 2. All right? Put the numerators, 2x minus 1. Now, I want to write x plus 1, but I want you to see what happens, because this negative sign here is going to be distributed to the x, making it a negative, and distributed to the 1, also making it a negative. So that's going to happen. And now you got to look at your denominators. Do I have anything in common? Technically, yes. X minus 2, x minus 2. They're on both sides. But what do I not have in common? This side has an x plus 2. This side does not. This side has an x plus 4. This side does not. So, with a whole expression, an expression being something plus something, or something minus something, I'm going to have to multiply this side by the x plus 4, and I'm going to have to multiply this side by the x plus 2. So let's write that out so you see the whole picture. Now what's my common denominator going to be? It's going to be x plus 4, x minus 2, and an x plus 2. All three expressions next to each other in parentheses. So let's show, what am I going to do here? I'm now going to say that this is, let's see, I'm going to keep it as a minus, and you're going to still see the x plus 1, just so that you know we will distribute this through. Okay, what's my common denominator? I'm going to have all three expressions. X plus 4, x minus 2, x plus 2, x plus 4, x minus 2, x plus 2. You'll see again, they shared the x minus 2's. That's with them both. But what was this side missing? It was missing the x plus 2. That's now here. So what do I have to multiply that numerator by? I have to multiply this numerator by the x plus 2. What you do to the bottom, you have to do to the top. What was I missing on this side? Over here, what do you not see? You don't see the x plus 4. So that's what I'm going to have to multiply this side by, x plus 4. Now I'm going to go through and distribute that negative so that you see, I'm just going to go ahead and change that to a positive because that's really a negative, and that right there is also really a negative. You guys remember when we had to distribute? It's like a double distributive property. Here, 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 and here, here. All right, you're going to distribute it. You're going to then have to combine like terms. And I'm going to try to save a little bit of time with you here. I'm going to expand it all out. All right, what's our common denominator? These three expressions. So let's write that down here one more time. X plus 4, x minus 2, x plus 2. Okay, you will use the distributive property twice on this side, and what's that going to give you? 2x squared plus 3x minus 2. If you use the distributive property here, this is what you're going to get. So take the time, work that out. Then you're going to use the distributive property here, and what do we get down here? You end up getting negative x squared minus 5x minus 4. All right, now in this numerator, there are like terms. What are those like terms? 2x squared and a negative x squared. What is that going to give you? That is going to give you x squared. So those guys are done. Then I have a 3x and a negative 5x. That's going to give you a negative 2x. That's done. That's done. And the final piece, negative 2, negative 4, giving you a negative 6. So that's my numerator. And what's my denominator? Again, it's all three expressions. So, for the final time, x plus 4, x minus 2, x plus 2. All, sorry about that. All of that is your answer. So again, take the time, watch it, rewind, especially watch this one and this one maybe 2 or 3 times, whatever it takes, and you guys are gonna make it, all right? I'm thinking of you guys a lot, all right? Praying for you guys. I pray blessings, peace, health, protection over all of you guys. Love ya, miss ya, and I will see you in the next video.